Let me request the panelists to introduce after I give a little intro on the format. The format is very simple. Once we start, I'm going to poll the audience and say, what category you belong to and so on, so that our panelists and experts will be able to focus and address on the demographics of who is here, number one. Secondly, I'm going to be asking questions or open discussion item actually. When it is done, I request the panelists to make it only one answer, not a series of answers, even though they know a lot. Right? Each one of them can cover the topic alone, but I request everyone to get a chance, like ask something, they say, then one more, they can come back again if something is missing. And if something is completely, not covered yet, I'm going to catch the ball at the end. I'm not going to do any of that. I'm going to let them do all the talking. My job is to put them on the spot, on a good spot, right? That's the thing. And let me start with the polling. I know that a lot of people are doing big data, and you may not be doing a lot, maybe doing a little bit. It doesn't matter. You work for a company, you are thinking on your own. Don't feel shy. Right? You can raise your hand 2 times so that they can see. Any time to cover more areas. Anyone who's already working on big data in any fashion, please raise your hand. Okay? And anyone who had done data mining or related in areas they want to get into data mining, big data, please raise your hand. And those who have not done in that area, but nothing wrong in it, there are new areas that come up, and you want to get into big data, don't feel shy, right? Good enough. And anyone who is in the other areas of big data than what we normally call as the processing part, but also business intelligence you have done. And what about data science? What about visualization? Anyone in strategy, corporate strategy, want to be in business development for big data industries? Good enough. I think we got a good enough sampling of who the audience are. So what I request is, even though your titles are known, what you do is known, make it very short, and say what you are, what is the thing that they should remember about you. Start with the, Mr. Bala Venkatrao.
Okay, good afternoon everyone. Hopefully you can hear me. It's great to be here.
You can use that. There's one more thing. It's one more.
Okay. So my name is Bala Venkatrao. I'm a director of products at Cloudera. So for folks who are not aware of Cloudera, so Cloudera is the pioneer in the big data space, bringing Hadoop to enterprises. It's a 4-year-old company. I've been in the company a little more than a year and a half, and I've really seen the whole space kind of take off and the customer traction and the use cases. So I'm happy to share the perspective. It's still early days, so there are plenty of opportunities, new startup ideas, and I think the big data space, it's going to be interesting for the next decade or so in terms of the value it can provide across the board.
Thank you. Mr. Sumeet Singh?
Sumeet Singh, Director of Product Management for Hadoop at Yahoo. And essentially we're part of a larger group called Cloud Engineering Group, which actually caters to all the users of Yahoo, all media properties that we operate globally at scale. So it provides Hadoop services and cloud services to all of Yahoo. We don't really sell anything, but I'll be happy to share my perspectives on what Yahoo has done in this entire journey of developing Hadoop, and then what we do today in terms of extending the Hadoop ecosystem through the community, and how Yahoo is leveraging the platform more and more.
Thank you. Mr. Stefan Andreasen?
Yeah, my name is Stefan Andreasen. I'm the CTO and founder of Kapow Software. And we are a software company, obviously, and the thing our customers use our product for is to help with the accessing data, connecting to data, If any of you feel that you have to run faster and faster every day because there's an information overflow, a data overflow, then you have a big data problem, and the one that Kapow Software helps our customers with is accessing the data. And specifically, our product turns the web into a read-write database. So any blog on any blog site or any price on your competitor's web store becomes yours, accessible in real time.
Thank you. Mr. Brian Johnson.
Hello, my name is Brian Johnson. I'm an engineering director at eBay in our search organization. And my team is responsible when you come to eBay, if you search for personal watercraft, to make sure you get jet skis also. If you search for jet ski with spaces or no spaces, with an S, without an S, all those kind of things come back. So a lot of query rewriting, query reformulation.
Thank you much. Mr. Anjul Bhambhri.
Hi, I'm Anjul Bhambhri. I'm the VP of Development of Big Data Products at IBM. So responsible for developing, we've defined the Big Data platform, delivered products, and I also have a customer engagement team that works with worldwide customers in different verticals and enabling them to understand what use cases, where to apply what technology, and influence the product direction based on what we learn from these customers. So we worked with about 200 customers in the big data space in the last 1 year.
Thank you. Don't you think we have who is who in big data from big companies? Thank you. And I am your surrogate. I'm going to ask questions that you probably wanted to ask. And I'm going to ask a very important questions. We have heard all kinds of information about big data, the 3 V's and the standard platform names and business intelligence platforms, the map reduce and so on and so forth. What I want to start with is, and the focus of this panel is, what is unique that people normally don't know about big data? Like they think it has the value is, it's not just the technology only, it is the business aspect of it. It is the utilitarian aspect of it. It is the way it would grow and what may be the hurdles. Is it all going to go and go away? Are there hurdles? Nothing wrong in understanding the hurdle ahead of time, whether it be software related, IT platform related, science, analytic part related, visualization part related, whether it's applicable to all verticals, or some verticals are going to happen earlier than the other, or is it other things like hardware, memory, is there enough memory, are there enough servers, based on peta, exa, and zeta, etc. that we will have. Hello? Yeah. At least you can hear us. If you cannot see us, that's okay. And someone will turn the light off. So if hardware is going to be an issue from any aspect of it, what are the network issues? That will not disturb us. Network issues in terms of latency, etc., is that something that we need to understand? Are there other issues in terms of deployment? Not enough people trained? Are there enough people in each area? And which country will take lead in some of these things as opposed to other countries? So some of these things that a lot of people do not talk about. Business, finance, and what is venture capital, investable, and so on. So we'll cover those areas. I'm going to start with one at a time. Give me your unique perspective that other people have not heard. Only one item, so it goes fast. And we come back. We try to do it in sequence, but once in a while I'm going to change the order. Please.
So the way I look at big data is it's enabling things which you couldn't do before at scale, which provides insights which just is not possible today. And I think a good example is one of our customers, Explorers Medical. They are a spin-off of Cleveland Health. and they are aggregating clinical trials information across a range of university hospitals in the US, and collecting all the information and providing the insight back to the hospitals. So things like, what are the trends in diabetes? Or how are diabetes correlated to other factors? And these things were just not possible before because the university centers were just doing it in their own silos, and they were able to just keep track of a few data points. But Explorers Medical they're using HBase, which builds on top of Hadoop, and they're able to store 30 billion data points. So it's a fairly big challenge, but the value it kind of provides, first is it's going to improve the overall health of us, all of us in the society, and help us discover things which was not previously possible. And just going back to the point is taking this technology and productizing it and solving a real problem. There are a lot of challenges along the way. Like how do you set up, how do you manage the infrastructure, how do you sort of set up such that data can ingest, reside in a HBase cluster, what kind of analytics you can do on top of it, and then provide it in a way which becomes easier for clinical folks who don't have any knowledge of technology but still be able to get the value from this data. So I think that's the horizon of where we are in terms of the influence of big data can have in our lives and in the society at large.
Okay.
Thanks, Bala. I'm actually going to provide a little more context in terms of a singular company. So, big data for us is really about extracting value out of the huge data assets we have. And just to give you a flavor for the scale and where we are, in fact, we tout ourselves as being at the cutting edge of scale. We operate the big data platform, which is primarily Hadoop and its ecosystem components, on about 42,000 nodes, 42,000 servers. We process about 140 petabytes of data. That's 1/3 of the storage size we manage in terms of raw HDFS. We're processing 100 billion events a day, so none of these was possible without a big data platform that we invested early on and heavily in. And in terms of Dr. Murthy's sort of question around, what's the challenges, what are some of the things we're looking at? Essentially, we're looking at stretching the boundaries, stretching the scale limits of the big data platform that we have built, primarily using the Yahoo open source projects. And we're also looking very closely into shortening the feedback loop from the data to the, I would say the results from the processing or downstream analytics that we do closer to the user. So think of as a user clicking an ad or a page and actually rendering the next set of ads, next set of page based on the user behavior, based on everything we know about that user, based on prior data and the current data that he clicked on. So really shortening that feedback loop with real-time systems is an area that we're actively looking at. The other would be performance, hardware performance, as Dr. Murthy talked about. We're again trying to stretch the performance limits on the specialized hardware that, well, it's commodity, but it's specialized for the workloads we have. So, improving performance of processors, improving the compression algorithms are some of the areas we're looking at closely. So resource management is a huge focus. Thank you.
Okay, Mr. Stefan Andreasen.
Thank you. So all of us hear a lot about big data these days, and I think whenever we see the word big data, we see Hadoop, we see NoSQL, we see analyzing web blogs on a mobile phone or shopping stores to figure out buying behavior of your customers, etc., etc., etc. And a lot of you think, well, big data is maybe not for me right now, but if you feel that there's an information overflow, if you feel that people around you, yourself, are running faster because there's more information, there's more documents you have to deal with, and more processes you have to deal with, or more customers you have to deal with, or more partners you have to deal with, then you have a big data problem. Because in my opinion, big data is a lot more than Hadoop and all of that. It's the explosion of data and applications and complexity we see in the world, and that affects every job function in a company. This is the legal department having more contracts to deal with. It is your procurement department who have more your suppliers in the Asia you have to shop against. And one of the biggest challenges in becoming efficient in the big data world is automation of dealing with all this data. And the challenge of doing that is connecting to the data. So think about this analogy, photographs, 10, 20 years ago, we had one camera, right? And it was spitting out only 36 pictures at a time. Today, we probably in the family have 5, 10 digital cameras. Then we have like 5, 10 phones, and they're all spitting out hundreds of pictures by the month or by the day. So, it not only is there an overflow of pictures, but there's also an overflow of sources to get it from. And so I think a big challenge and a very important part of big data is connecting to this explosion of the places where you get the data, and then of course getting insight out of it. And that's really what we are helping our customers with, connecting to the data. So,
thank you. Great answer.
Hello. I'm an engineer, so I'm going to speak mostly to the engineers. And tell you what I think you should do if you're interested in doing software engineering in the big data space. So to me, it's pretty simple. It's all about, a lot of it's about counting, right? Where you have a lot of data and you're almost always processing it mathematically. So artificial intelligence many years ago was very semantic. People wanted to have large knowledge representation databases and try and figure out the semantics of meaning. And really, I would say it's bean counting that saved artificial intelligence. It's all math now. Machine translation is a lot of just correlations of word. What word's likely to precede this word or follow some other word. So it's an awful lot of mathematics. And there's some really nice resources to follow up on if you're interested in changing your career. So I myself took the Stanford online machine learning class last fall, and I think there were 50,000 people in that class online, and it's free. And Andrew teaches it, and it's awesome. Like there's a whole bunch of Stanford and Berkeley free online classes. So if you're interested in moving into these things, take some of these. And if you're engineers, you probably are engineers because you're already interested in math. So much of what we're doing is I do a lot of log analysis at work. So we're just counting paths. It's kind of like looking at the woods and seeing where most of the people walk, and then you try to figure out where they get stuck. But it's you're not doing it one path at a time. It's all mathematical. So. Invest a little bit, take some of the free online classes, and check out machine learning because it's really making changes in a lot of different fields and a lot of different areas.
Thank you.
Thanks. So, I really see big data as it's a very disruptive technology. We've been working with enterprise customers for a long time, and the problems that they were solving before and using the technologies before, they are not just going to scale to, at the volumes of data that are being seen, the different variety of data that is being seen is just different. So if you look at like the retail industry, right, when they are trying to understand their consumers, what are their customers saying, what products are they liking, what are they not liking, what is the point of sale data telling them. If they were to continue to just look at the data that is in their warehouses or in their CRM systems and not leverage the social data that is out there, they would miss out on a lot of opportunities. So it's in the retail industry, we are seeing that it's becoming very critical for these enterprises to integrate and leverage the social data along with the rest of the data that they were already capturing. And missing out on that is something that they cannot afford to do. So for the next decade of what is their enterprise information management going to look like is not going to be just what it looked like in this last decade. So retail is one example, right? So when you look at like financial sector, credit card companies, fraud detection. Credit card fraud detection has been happening forever, but what they're able to do now, leveraging these new technologies, is they are able to bring in, ingest instead of say 30 days of transactional data, they can look at 7 years of transactional data. Because it's possible to do that. I think somebody had made this comment in the panel or in one of the keynotes. It was just not possible before because the cost of hardware, procuring all this data, and if you have to set up systems where you have to analyze 7 years of data and the time that it would take to do that, it would just be cost prohibitive. Same thing from a healthcare standpoint, right? I think it was pointed out earlier that there is a lot of data that gets gathered, right? But it's how do you analyze all of this data? So it would get, we've done some work with University of Ontario in Toronto. This is around premature babies in a neonatal center. And there is 1,000 pieces of information that get generated per second, which would be netted down to one aggregate reading, which a doctor or a nurse on duty would look at that reading and say, okay, is the pulse rate normal, heartbeat normal, move on. But when they and these babies, which seemed healthy, were still coming down with infections 24 hours later. So that means there was clearly data that was indicating that something is not right. But how do you analyze 1,000 pieces of information per second, which is the speed at which this data is getting generated? And now it's possible to do that. So when you look at, same thing, telecommunications, right? It doesn't happen as much in the US as you would see in like Asia Pacific. Customer churn is a big problem. And traditionally, they have been using warehouses to store a lot of information and build these predictive models which would tell them whether a customer is going to churn or not. Now, everybody has a phone. Everybody has multiple phones like was mentioned before. So the volumes of call data records or IPDRs that have to be processed has gone through the roof. And if all of that data has to be cleansed, and this data is noisy data too, and if all of that data has to be cleansed and put in the warehouse, and then you get a report saying, oh, this customer is going to churn versus not, by the time the customer is already churned and maybe is ready to churn again. So you need this new technology in all of these industries to really handle these large volumes of data and to deal with this data, to analyze all of this data in almost as real time as possible. The time lapse or the latency requirements which are needed to analyze some of this data are different now than they were before. And while there is all this technology that is being developed, there's of course the question of where do people get started? Whether it's in terms of identifying what challenges they want to address first from a business standpoint, and then for the IT department, that how do they build a big data platform or a data platform that is not just going to be what it used to be, but bring in these new sources of data. So challenges lie on both sides. And when we work with customers, we work with both the IT side as well as the business users, because both have to understand what is the value in bringing this data into the enterprise, and for the business users to say, okay, what's the ROI going to be? And at least my response to them is the ROI is that you are not able to analyze all of this data. You are analyzing a subset of this data. So now that you can analyze all of this data quickly is obviously a return on investment, right? So there are new possibilities which were not there before. And there are various sources like have been pointed out, whether online courses, there is, I think if you search on big data these days, it's a question of do you have the time to go through all of that? The information is certainly out there.
Thank you much. And let me start with Mr. Johnson this time. I don't want to change order this time, right? As I said, I want to start with you to answer this question, and others will join later. What do you think is missing? Completely missing? Is there anything missing at all? Is everything already there for big data to roll out in big time, in all verticals, all areas? Are there anything missing in terms of people. If you wanted to hire, as the data grows, as you need to analyze a lot, you need to do a lot of work in big data. Is there any issue in any aspect of it, from people to network to hardware to memory? So start with anyone one at a time.
Yeah, I'm going to answer with respect to the type of people that I'm hiring. I guess it's
Exactly.
a career fair.
That's
People
what
are looking for jobs. Of course, I'm hiring also, but we're hiring in those areas because that's where we have the work to do. So we collect a lot of data now, and I wanted to mention one thing that's interesting about a lot of this data is it's important to collect what people don't do actually as well as what they do. You know, what items that they click on eBay as well as which items they don't click on. It generates a lot of data, and so the thing that we're all looking for, what's driving this whole business is costs have come down, the value's always been there, so now you're getting a return on investment that you could never achieve before. But there's this transfer function, you've got a whole bunch of raw data, and what you'd like to get out the other end is profit, and I don't measure profit directly, but I measure revenue directly. So you've got a lot of raw data, so now on eBay I have all the click streams of all the users, I'm trying to match them up, buyers and sellers. And I want to generate revenue at the other side. But that transfer function from raw data to revenue is not so trivial, right? That's what people are working on. So I'm hiring engineers so that we can spend time, do all the feature factor engineering so that when we think somebody's going to churn, now we'll look at a user, maybe we'll generate 1,000 different variables, right? When's the last time they bought a phone? How many people are in the family? How much money do they spend? How often have they used their phone? And we'll generate a bunch of factors and then drop them into probably some sort of machine learning model to classify whether we think they're going to churn. But it's that feature engineering is actually pretty valuable, and it's a pretty big part of what a lot of people are doing in data analysis.
Yeah, Mr. Stefan Anderson.
So I think if you realize how big is big data really, think about the fact that over the last 2 years, half of all data in the world was created. And then think about where that's going. So I think what we need is a lot of new technologies and a lot of new skills we just don't have yet. We are seeing it coming with the value pair databases like Hadoop, with the new analytics tools, with ways to access, when people are writing about you on social media, understanding the voice of the customers and all of that stuff. But I think we'll see a lot of more technologies evolving, both in storage and analytics, in data access, and in storing data. I think we will also see that people will have to find out a way how to filter the data so that they can be more efficient. Yeah, so I think there's a lot more to come, and a lot more challenges to come, and the world is going to get more and more complex. The one thing I will say as a big problem is the diversity of the data. We heard about the 3 V's that was mentioned. Dr. Murthy in the beginning. The 3 V's is a term invented by Gartner. It means volume, velocity, and variety, which are the 3 V's that many people associate with data. But I also talk a lot about the 4th dimension of big data, which is this explosion of sources of information. And I really think that's going to be a major challenge going forward. How do we connect to the data that is basically everywhere? Think about the fact that there's between 20,000 and 40,000 new websites launched every single day in the world. That's an explosion of places where data exists. And if something that's really missing in the stack of that people are talking about the big data, I think is addressing that problem. Because that is going to be a huge challenge too.
Thank you. Ms. Bhambhri, you want to take it and then I'm going to come back so that will change out a little bit.
So in terms of the challenges, right, so we talk about that there's all this volume and variety of data that can be analyzed, and you can build, let's say, better fraud detection models or better asset management, asset placement models, better customer churn models. But when you actually go through the whole life cycle of building the model and verifying that is this the right quality right? Is this really improving catching that fraud or the customer churn? That is still not easy, right? So there's a lot of magic that we all talk about, that, okay, now you can, catch customer churn, but that whole life cycle of building these predictive models and testing those and really finding out, is this the right, you can imagine that now that the volumes are so large, visualizing the results of these models has become much more challenging. And do you move all this data to where these algorithms can be built, or we still are waiting for that these algorithms can move to where the data is. So we are still seeing that the data is being moved to the function, but what we need with big data is that the function needs to move to the data, right? Because if moving these petabytes of data, doesn't matter which modeling tools, technology we use, but this is still something that I think we still have to see more technology advancements there. And then in terms of visualization, right, just testing these is hard. So those would be...
Thank you, Mr. Singh. What do you think?
So from a challenge perspective, I think what we find ourselves in is that there are a lot of people who've moved in the space and are extremely excited about the newer innovations, technologies that are shaping up in the marketplace, and they want to put that into good use as part of our platforms. And not realizing that we have about 5-6 years of investment in building this big data platform that we pretty much bet our entire business on. Think of a single product line, which is, let's say, display advertising. It's over $2 billion in revenue. It's all running on the big data platform that we've built. So, we are constantly looking for people who have ideas to bring all this thing together as part of a single infrastructure, a shared infrastructure, understanding what's been done in the past 5-6 years and actually solving the problems in the realm of what exists. That's a really important issue. In terms of, Brian made a comment around career, so I actually am passionate about that. I think I switched into the space recently, about a year ago, from the networking infrastructure space, and I was a strategy consultant too. So it's exciting for me to actually see the problems we solved in the internet space and bringing the strategy elements into my current job. So I think there are a lot of exciting possibilities, be it a data scientist type role where you build models and put that on good work right there at scale with the infrastructure we have, or you are an analyst. User data analytics is a huge group that we operate currently that pretty much provides all the analytics, all the insights to both our consumers and advertisers. Visualization is an area where we have done some work. If you go to visualize.yahoo.com, you can see some of the work. So that's an exciting area, really exciting area. I talked about analytics. If you're passionate about building products and operating those products as part of the platform, so really building the enablers for processing big data, our group actually is looking for talented people. So there's no shortage and no I would say, it's just a question of how passionate you are about solving these problems, and then you can find a spot in any of these groups that has to deal with data, be it platform, be it the end user of these platforms, or any of the, I would say, modeling type work, research type work, or visualization type work.
Thank you, Mr. Bala. Venkatrao.
So the way I see it is, so big data is still in a very early stage, and there are a lot of moving parts. And when I sort of think about big data, I kind of think about it as like a stack. So you have the platform layer, and there are a lot of players here, including Cloudera, who are providing the basic platform to drive the big data sort of revolution. So that's at the platform level. And then you need a consumption layer. Like, how do people actually get access to the platform, right? Like, whether it's BI tools or developer tools, how do you make it easier for developers to run MapReduce programs, or like through Hive, SQLite, but how do you make sense of all of the data? And lastly, you have the application layer, right? Are there like cookie cutter applications? So sentiment analysis, that's a classic use case of big data And sentiment analysis is something which is getting the attention of CMOs across different industries, right? So all of these three things, the platform, the consumption layer, and the application layer, all of them have to come together to solve a business problem. And I see tremendous opportunity for folks to really architect the solution. There's a big gap there, right? Because there's so many moving parts, so somebody needs to step up and say, okay, here's what the architecture looks like to solve the business problem. And if you can do the job successfully, you will be really in big demand, in huge demand. Because there's a paucity of skills. There are a lot of options at every level, at the platform level, and even before the platform, you have to make hardware choices. So somebody who can think through end to end, build the whole sort of solution and offer it to the customers in terms of solving a business problem, I think that would be great. The other aspect is all about data sciences. Even after you have the platform, you have the data, there's still a human element to make sense of all of it, right? Algorithms can do only so much. You can run algorithms to get fancy results, but somebody needs to look at the results and make sense of it. And I think there's this whole new notion of data scientists which are emerging, and it's going to be interesting. That I think that field is going to become even more exciting because it's a combination of computer science, statistics, and you need to sort of like figure out what new algorithms you can cook up. And you have all the data which is available to you now. So that's the difference, right? How do you make sense of the data to extract value and do things which you're not able to do before to add value to the business? And a data scientist will emerge as a distinct, sort of like a distinct vertical, and which will provide a lot of opportunities.
Thank you. And I know that they can go on with so many things. I want to give opportunity for the audience. If you have any questions, raise up and ask as loudly as you can, but we will repeat the question for the benefit of other people. Ask away whatever questions you always wanted to ask the experts who are in the field, in the companies, in big data. Anyone? Please, start with you. Yeah, go ahead. He's a student, so I'm just giving him first choice. Yeah.
So I was reading this book on Hadoop, and they made the weather data available for download so that we can run our map and reduce function on it. So I was just wondering, like Google collects so much data against IP, against humans. Where can we access Google data? Because tomorrow if I want to make a software to find out how my to-be wife would be in her psychology, like, I want to analyze her web footage and what she has done on it. Because I've come across softwares that you answer 50 questions and it'll tell you, oh, you're a teacher, you're an extrovert. So what if I analyze like her 7 years of internet search results and I find out that she is this, that, and that? How do I get hold of Google's data? Like, is there any API, is there any AJAX call, is there any tar file, where do I get it from?
Anyone who wants to take it? Okay, go ahead.
Well, so it's not that straightforward. The data that you collect from consumers, it's not that easy to make it available for public use. There are a lot of compliance issues around the nature of data that you collect. There are some that you can make available, but there are many others that it's not allowed for you to actually make available, or even, I would say, commercialize that. So, for example, there are Twitter feeds available for you to buy. There are Facebook graphs, social graphs available that you can get to. And there are companies that actually are in the business of aggregating these feeds and data, but not all, not what you searched for past 7 years can be made available, unfortunately.
Any more questions? If someone has, go ahead.
Hi, my name is Sundar. I'm a PM at VMware and work on big data. In your mind, I can talk maybe Anjul and Bala, you guys. In the applications packages space, what are some of the interesting companies that you see? And what are some of the challenges that you see in terms of the packages?
Someone else can answer. Anyone else?
Either one can answer, or just answer.
Everyone should get 10 seconds. Can you repeat the question?
I think Sundar's question was in the application space for Hadoop, what kind of applications you're seeing, basically. And are there sort of like shrink-wrap applications, out-of-the-box applications? And I think it's early days for that, right? Like most of the customers I speak to or I deal with, they kind of build custom applications. So they have teams of engineers who are kind of figuring out how to use this software is our platform, and then maybe use like some kind of consumption tool and build an application specifically for them. So we're starting to see this notion of like a lot of companies providing services like big data as a service, like there are companies like Cloud, which are doing recommendation engine. And so they are kind of doing sentiment analysis or recommendation at the individual user level. They're making it available to end users. Will those kind of applications proliferate enterprises? You bet, right? I think that's why like Axel is keeping aside $100 million for a whole new breed of entrepreneurs to start building, let's say, CRM applications, or as I mentioned, sentiment analysis application, right on top of the big data stack. But there still needs to be a little bit of a standardization. Things are moving, platforms are still kind of evolving. So ISV is a little hesitant to figure out where should I place my bets, right? Is there like a standard API? If I build against this platform, can I just move to this platform? So that will kind of like firm up in the next 12 months or so. And you will see, I'm sure you will see ISVs who build applications, because if you look at it from the enterprise perspective, they want to solve a problem, but at the same time, they don't want to be investing enormous amount of time and resources to solve the problem. So if there is an ISV or there's an application which they can procure and solve it for their needs, they'd rather go that way.
Anyone has answer for this?
Yeah, so I agree with Bala. There's obviously custom applications. There are shrink wrap applications, especially when you see around understanding the customer sentiment, the buzz. What is the customer's buying behavior? When there are ad campaigns, right? What's the effectiveness of the campaigns? So there are different aspects that people have taken, and now. The key would be that if that's the only thing that's needed, then it makes sense to go with that shrink wrap application. But lot of, the space is still evolving, so it's important that those applications, right, they have to be also extensible. That if some other aspects need to be analyzed, then, can your custom application work with that application? So that's why the whole integration aspect around big data with custom applications and shrink wrapped applications, right? That the big data platform really has to support that.
Anyone else? Please.
I think the question you ask is at least the question I hear everywhere, and I think it illustrates that big data is still early on. The only real application I heard repeatedly is really around analyzing shopping behavior or consumer behavior in some way through log files or other stuff. So it'll be exciting to see what's coming in the big data world.
Any questions? Any more questions? Yeah. Please go ahead.
So one of the issues in big data is validating the test results. So many times you'll have it sharded across multiple data stores. You go out and do a query, and sometimes it doesn't return the results you expect. And sometimes it's very difficult to debug what the issues are. Can you talk a little bit about some of your experiences there and some of the results in the
So we have that challenge. It's a serious challenge. And what we have done is that we have invested in a series of tools. Some of these are open source. All the way from, let's say, figuring out how much capacity would you need to process the jobs that you have and the time that you need. We have invested in tools that injects faults in clusters, like really simulates error situations and to figure out what happens. We also have invested in tools that will fork out the production jobs from the production cluster to a test cluster and test the results over there in a smaller control, less, I would say, serious environment where you can go experiment with and figure out what went wrong. So there are a series of tools a lot of companies are actually investing in. I would say either the management tools, test tools, tools that will validate your results. We have things that will actually do a prescriptive analysis. We call it by this, so it goes back, looks into the logs.
Mr. Johnson?
I'd say, I think from an engineering standpoint, you're kind of talking about unit tests. So when people write unit tests in small pieces of code right now, there's not very much data. When you're looking at gigantic log files, it's really hard to write unit tests in Hadoop and run the unit tests. So that sounds like that's kind of what you're asking. So I think what you need to do is cross-validate your results with other data sets. So if we were doing computation in Hadoop, then we also have a data warehouse at eBay. A lot of times we'll validate our Hadoop results against data sets we've already got And the other thing I think you can't do too much of is looking at particular user examples. So we do a lot of what's called dog fooding, right? So we'll look at particular queries, or we get complaints from customers, and then we'll dig into one particular query deeper and deeper and see if we see anomalies in data. But it's not easy. I mean, to some extent, sometimes debugging in Hadoop is almost feels like it's a throwback to print line, right? Which is pretty tough, you know. And if you think about printf statements in a distributed system, it's even worse. So, but I think cross-validating with other data sources is incredibly important.
Thank you.
And then you have to do A/B tests.
We really want to be talking to you till midnight, right? But the organizers don't want us to continue because other people need to get some time. So what I recommend is that if you have any questions, feel free to send it to them directly, or send it to me, or pass it along. We can create a group for people to discuss and create a community, whatever it takes to do. My responsibility is to be your surrogate. And as your surrogate, can I thank the speakers and panelists who gave their perspectives. Mr. Bala, Mr. Singh, Mr. Stefan, Mr. Brent Johnson, Ms. Anjul. Thank you a lot, and we will follow up. Ask questions anytime during the break. Don't leave them alone. Thank you.